So on the homework tonight for 3.4, when you get to the part where it talks about percentiles, the book does it weird, does it differently. So remember how I said you find out how many people you beat, and you turn that into a fraction? Like I beat 7 people out of 40, so 7 over 40, and change that to a percent. Your book counts half of yourself. You beat you as beating half of yourself. Is that, you see what I'm saying? Like half of me is higher than me, and half of me is less than me. Do you see, kind of, you know what I'm saying? Kind of annoying. So if I beat 7 people, I really beat 7.5 people, and that's how it calculates it. So think of it as splitting yourself down the middle, and you beat half of you, and then you're less than half of you. It's sort of a half, you know. So count yourself as half of a person that you're beating. So if you beat 6 people, then it's really 6.5 out of 40, and then change that to a decimal. And that will, or change that to a percent, and then that will make that problem go better for you, and you won't be like, what the heck? All right, so let's go ahead and go through this. Rob, are you done?
Yes.
Perfect. Oh, look at that. Great use of color. So, you guys listen up. Rob is maybe going to explain what he did, if I can get this to work. Oh, there we go. Okay. Rob, go ahead.
Basically, just change the numbers that you circled in green for the first one. If x is 4, then it's 5c4 times your little p to the 4th power, and then 0.7, which is cubed to n minus x. And after I plugged it all into the calculator, that's where I got 0.02835. And then for x equals 5, the same thing, just change all the numbers in green again. So that one, yeah.
Good. Right, remember, those are the only things that change. Perfect. And then, what did you do at the end?
And then at the end, add them all up.
Because it could be, you know, at least 3 means it could be 3 or 4 or 5. Okay.
So I have a question.
Yes, totally.
Okay, so you just mentioned that you want us to do the work to the 4th decimal.
Oh, right.
The final
And
answer
then,
to the 3rd.
and then round it off to here. So then I want 3 sig figs at the end.
No, oh, aren't they?
So at the end, so along the way, give me 4 or 5 sig figs, but at the end, then you round it off to 3 sig figs. So that's what Jaime was asking about earlier, right? Was along the way. This is along the way. Do you guys see what I'm saying? These are all along the way calculations. They're not the final answer. Give me 4 or 5 decimal places, and then when you get to the end, then round it to 3. So my final answer would be 0.163. Good. All right, now we're going to take a look at, before we take a break. Oh, here it is prettier. It's not much prettier because Rob actually made great use of color. Thank you. We're going to do lab problem number 8. So let's take 30 seconds with our neighbors and figure out, again, the problem itself. You guys listen up. The problem itself will have an n and a p. The thing that varies down here is going to be your x's. So figure out what the n and p are. It's inherent in the problem. It's fixed. So 30 seconds, 15 seconds with neighbors, find the n and the p. Go.
So n equals 5 and p equals 0. 0.4, yeah.
Okay, guys, what is our n?
5.
Yeah, our sample size. Random sample of 5. That's my n. And then what's my little p?
44.
Yeah, 40%. That's my little p. Everybody good with that part? So then my x's will change. Right here, for a, x is going to be exactly 2. For at most 3, what would you say at most? I can have at most 3 absences. That means how many absences can you have? Can you have 5 absences? No. Can you have 0 absences? Yes, so it's the lower end. Can I have three absences?
Yes.
Yes, if you have at most three, you can have three. So it means three and less. So here, X would be, figure out what that means. All right, so I'll let you guys spend, oh, and then here's a hint. Do not calculate more things for C. To do C, you're just going to do subtraction or addition, that's it. So don't do anything else, don't do all the fancy stuff you can do for A and B for C. We'll go through it after your break. So work on it for 5 minutes and then we'll take a break. How's it sound? Why is this, oh, I know why. Okay, so let's go ahead and take a look at what we've got. So the probability of, for B, we need to find the probability that X is 0, the probability that X is 1, and the probability that X is 3, because we already have 2, so we don't need that one again. So 5 choose, right? Then 0.4 to the something and 0.6 to the something. And again, these are going to be the things that change each time, right? So it's going to be 0, 0, and 5. 5 choose 1, 0.4 to the 1, 0.6 to the 4. And this will be 5 choose 3, 0.4 to the third times 0.6 to the second. So what did you guys get for the X is 2? Anyone?
0.346.
3, 4, 5, 6.
5.
Yeah, so again, give me like at least 4 decimal places before the final answer, and then that way you can round correctly for the final answer. And then for X is 0, do I need to start calling names? Stefan, what'd you get for probably X is 0? 7, 6, 7, 7, 7, 8. And then, Allie, what'd you get for probably X is 1? 592. And last one, Ujwala, what'd you get for probably X is 3?
0.3456.
No, X is 3. Okay, perfect. And let's see, when you add them all up, Adam, what'd you get when you add them all up?
I got one of them wrong.
Okay.
So-
Clayton, what'd you get when you add them all up?
0.91296.
296. So we can round that to 0.913. Is that what people got?
Yes.
Okay, perfect. Is that everybody all on board with that part? Now, let's take a look at C. C, we don't need to do any extra work for C. Here's the deal for C. At least 2 people agree with this statement. All right, what are my options? 0, 1, 2, 3, 4, and 5. I have 5 people, so I can have 0 through 5 possibilities for X, right? What is at least 2? At least 2 means who?
2 or greater.
2 or greater. 2 or greater. That's these guys here. Yes? Now, what's up with these probabilities plus those probabilities? They darn well better all add up to what?
1.
1 or 100%. If I add up all those probabilities, they have to equal 1 or 100%. So if I want the red stuff, and I already calculated the green stuff, I don't need to do any more calculations. You guys see what I'm saying? I just have to take 1 and subtract these 2 things, and then I'm golden. Good? So on the exam, especially on the exam when it goes out to 8 or 9, right? When I say probability of at least 2, then just find the probability of these guys and subtract from 1 instead of finding the probability of 2, 3, 4, 5, 6, 7, 8, 9. Which some people will do, and you can do it that way. It just is going to take you more time on the test. Okay, so here we would say, all right, 1 minus the probability that X is 0 minus the probability that X is 1. So that's going to be 1 minus .0778 minus .2592. So I'll go into my calculator.
0.337.
What was it?
0.337.
337?
0.3369.
1 minus .337, is that what you got? So .663?
Yeah.
Okay, that works. Good. So he's combined these two, he added these two together and just subtracted them. This is, you can do it that way too. Or you can subtract them individually, you get the same answer either way. All good?
I got like 0.776, it's like 0.778.
Oh, yeah, you gotta be careful. Whatever you type into your calculator is what your calculator will do. So you gotta watch the points and the zeros and make sure you have them all right in there. Okay. Good. Binomial distribution. Let's move on to our last part of this section. Megan, go ahead, read for us.
The mean, variance, and standard deviation of a variable that has a binomial distribution can be found by using the following formulas.
Great, thank you. Binomial distribution is my favorite distribution. This is why. The mean and the standard deviation are super doggone easy to calculate. Super easy. The mean is just NP. The variance is just NPQ. And the standard deviation is just the square root of that. Square root of NPQ. Super straightforward, super easy. This should be in your notes. You should make sure maybe circle it, write it down, whatever you need to do to make sure you remember it. It's very, very, very useful and helpful and necessary. Here is an example. Let's get a reader. How about Noe? Go ahead and read.
The statistical bulletin published by Metropolitan Life Insurance Incorporated reported that 2% of all American births result in twins. If a random sample of 8,000 births is taken, find the mean variance standard deviation of the number of births that would result in twins.
Great. So we need to figure out what our N and our P are. I always have to give you N and P in any binomial problem. So everybody take 15 seconds with your neighbors, find N and P, go.
Yeah. And it's 8,000. And we 0.2.
Okay, so what is our N? What's our sample size?
8,000.
8,000. Random sample of 8,000. That's our N. 8,000. Okay, and then what's my little p?
0.02.
Yep, 2% of all Americans. That's my little p. 2%, how do I write 2% in terms?
0.02.
Yep, I write it as 2 cents. 2%, 2 cents. If I spend 2 cents and give them $1, how much change should I get back? 98 cents. There we go. So my N is 8,000, my P is 0.02, so my mu, my mean is going to be, here, I'll write the whole thing out here. NP, which is 8,000 times 0.02, 160. My variance, NPQ, 8,000 times 0.02. Well, you know what? I'm going to do it the shortcut way. I already know NP. What's NP? 160. And then I just multiply by Q. What's my Q? 0.98. Perfect. And then I'll get 160 times 156.8. And then I need to do my variance. Sorry, that is my variance. My standard deviation. Square root of NPQ. So that's the square root of 156.8, which is, and this is how I do it. I have my number here. I want to square root that. The easiest, fastest way for me to do it is to raise it to the 1/2 power, because that's the same thing as square rooting something. So I'm going to raise it, here's my exponent part here, raise it to the 0.5 power. And then I have it, 12.5. So raising something to the 1/2 power, this is my raising to, my exponent, raising it to the 0.5 power will give me that. And it works on, whatever your last thing is. So if my answer was this, it just takes that number and does that to it. Another way people do it is, say you have this number, they'll do second, and then see where it has a little square root thing here in blue? They'll hit that one, and they'll do second answer. And answer is A-N-S right down here, answer. And then that will also get you the same way. That way you have to retype it all in all over again, which just gives you another chance to make an error. Yeah, Noe?
You can also just hit the up button and hit enter on that number, and it's like hitting the answer as well.
This one?
Yeah, so it's the square root, like you first did.
Like that?
Yep, and then go up to 156.
Oh, only if you have a fancy calculator.
Oh,
So
yeah.
if you have a fancy calculator, it'll let you arrow up, it'll let you move your cursor up so you're actually on it. Mine won't let me do that because I don't have, but yeah, if you have the nicer, the later model 84s, then, and the color 84s, then you can do that too. You just arrow up and you can just select it. Totally. That's a good point. Okay, good deal. So why don't you guys do problems 9, 10, and 11, all the rest of the page. Just work on them.
The decimal thing still applies if the mean is no decimal place, you just have to add one, right?
Well, these are all, let me see what the book would do with this, because these are all kind of weird. They're probabilities, so they just rendered them the nearest whole number.
Okay.
Yeah. I'm fine with 1 decimal place.